Welcome to this explainer. Okay, today we are unpacking something absolutely wild, the vagus nerve. If you've been following this space, you know it's the 10th cranial nerve, basically the ultimate living cable inside you. Vagus is actually Latin for wandering, and honestly, it completely lives up to that name. It snakes all the way down from your brainstem, right through your throat, and just branches out across your heart, your lungs, and your gut. It is literally the physical bridge connecting your mind and your viscera. So let's dive right into this. We naturally tend to imagine our mind sitting up there at the very top of our body, issuing commands downward like a general barking orders to the troops. But does your brain really control your body? Or is it actually the other way around? As we're going to see today, the vagus nerve totally flips this script. It hints that the state we call calm isn't just some top-down decision your brain makes, but a continuous bottom-up negotiation.
Here's the roadmap for today's explainer. We're going to start with the body's calm cable, then learn about reading the vagal brake. After that, we'll hit polyvagal theory and safety, quieting the immune system, psychedelics and the vagus, and wrap it all up with the science versus hype.
Let's do this. Section 1. The body's calm cable. Let's explore the actual physical mechanics of your autonomic nervous system. To really get a grip on the vagus nerve, let's just do a super quick refresher on the two main branches of our autonomic nervous system. You know the sympathetic system, that's your body's gas pedal. The classic fight-or-flight response, right? An adrenaline surge that speeds up your heart and gets your body ready for action. But on the flip side, we have the parasympathetic system, which is essentially the brake. This is your rest and digest mode. The vagus nerve, it's the principal cable of this parasympathetic brake. When it kicks in, it slows your heart down, deepens your breathing, and just settles your entire body into a state of safety, repair, and restoration. But honestly, calling the vagus nerve just a brake kind of understates what it actually does, because most of its traffic runs the other way. Which brings us to a pretty fascinating question. Where do gut feelings actually come from? Think about that physical sensation of, say, unease, or even ease, right in your stomach, when you walk into a room. Well, this brilliantly illustrates what's going on. Notice how roughly 80% of the fibers in the vagus nerve are sensory. This means they are traveling up from the body to the brain, while only 20% travel down. The vagus is continuously reporting the physical, on-the-ground state of your organs, your heart, your lungs, your gut, straight upward into your brainstem. It forms the literal gut-brain axis. So when you get a gut feeling, you are quite literally experiencing biological information traveling up your vagus nerve.
Wild, right?
Moving right along to Section 2, reading the vagal brake. If this nerve is constantly working behind the scenes, how do we actually know how well this internal braking system is holding up? Amazingly, we don't need to do any sort of surgery to measure it. We can read it right in the heartbeat through something called heart rate variability, or HRV. See, a healthy heart doesn't just tick perfectly evenly like a metronome. It fluctuates beat to beat along with our respiratory rhythm. Try this with me really quick. Take a deep breath in. Your vagal tone actually eases up and your heart speeds up just a little bit. Now breathe out, and the vagal brake reasserts itself, slowing your heart back down. This natural respiratory rhythm gives us a direct, non-invasive readout of your vagal activity. And this beat-to-beat flexibility matters way beyond just basic cardiovascular health. Researchers Thayer and Lane put together this model called neurovisceral integration. Basically, they showed that the exact same prefrontal circuits in your brain that regulate your emotions also govern this vagal brake. This is exactly why your emotional resilience relies so heavily on your biological state. High HRV generally signals the stronger, much more flexible vagal brake, which tracks with better emotional control and stress resilience. Conversely, a chronically low HRV is associated with things like anxiety, depression, and burnout. Your body and mind are literally holding each other steady.
Okay, let's hit Section 3, Polyvagal theory and safety. Let's see how this biological brake connects to our social interactions and how we actually feel out in the world.
So how does this all build into Dr. Stephen Porges' highly influential, though I should mention heavily debated, polyvagal theory? Well, under this framework, mammals evolved a specialized ventral vagal system. But get this, it doesn't just slow the heart. It's biologically wired to the muscles of our face and our voice, creating what Porges calls a social engagement system. According to this theory, when your ventral vagus is well-toned and active, it produces a gently braked heart, an expressive face, and a warm tone of voice. It basically proposes that safety isn't just some abstract mental thought, it is a physiological state of calm connection. Central to all of this is a concept called neuroception.
Think of neuroception like this biological radar that's just constantly pinging in the background, unconsciously scanning your environment for cues of safety or threat, and this operates completely below your conscious awareness. If it detects safety, the ventral vagal brake engages, allowing for open, calm connection. But if it detects danger, that brake releases, handing control right over to your sympathetic fight-or-flight surge. And if it detects an overwhelming, inescapable threat, an ancient dorsal vagal circuit can actually trigger a sudden shutdown or freeze response. Your body is automatically shifting these states based entirely on what it perceives.
Which brings us to Section 4, quieting the immune system. We're going to introduce a super surprising biological bridge between this nerve and physical illness.
Now, what's really interesting here is that the vagus nerve doesn't just regulate mood and heart rate, it can literally quiet inflammation down in the body. Back in 2002, researcher Tracey described the cholinergic anti-inflammatory pathway, also known as the inflammatory reflex. Here's how it works. Signals traveling down the vagus release a neurotransmitter called acetylcholine. This acts directly on immune cells to suppress the release of inflammatory cytokines. Essentially, your brain is using the vagus nerve to put a physical brake on the immune system's inflammatory response. A calm, well-toned vagus literally helps keep inflammation in check. It's definitive proof that psychological calm and physical health are just deeply, deeply intertwined.
Next up is Section 5, Psychedelics and the Vagus. We're shifting focus to a really complex, emerging area of research at the intersection of altered states and the nervous system.
So there's a pretty common misconception online right now that classic psychedelics just magically switch on the vagal calm state. But physiologically, the source text neutrally points out that they actually do the exact opposite acutely. Psychedelics act as a massive accelerator. They activate the sympathetic system, jacking up your heart rate, raising blood pressure, and dilating your pupils. They're absolutely not purely parasympathetic relaxants, and they carry specific cardiovascular risks because of this acute arousal. It is so important to understand the actual biology here and not just the hype.
So you might be wondering, how does the vagus nerve even factor in then? Well, it enters through the safety of the environment. The entire architecture of set and setting, having a trusted guide, comfortable surroundings, a warm voice, all of that exists to create a neuroceptive safety container. It turns out those comforting surroundings aren't just for good vibes. They are actively keeping your social engagement system online, even as the drug drastically intensifies the experience. The vagus isn't just a switch the drug flips. Instead, traditional practices like slow breathing, singing, gentle touch act as vagal tone practices that strengthen that internal brake. This safe container is what allows a person to face really difficult psychological material without tipping into threat mode and shutting down entirely.
And this perfectly leads us into our final segment, Section 6, the science versus hype. Because this topic has blown up so much recently, we really need to carefully separate the established facts from speculative hypotheses.
So, the crucial point here is that we have to objectively look at what's proven versus what is still being figured out. On the one hand, we have established uncontroversial hard science, the anatomy of the vagus nerve, using heart rate variability as a window into emotional regulation, and that incredible inflammatory reflex we talked about. Those are facts. But on the other hand, we have emerging ideas. Stephen Porges' polyvagal theory, incredibly influential in clinical trauma therapy, but its specific evolutionary claims and those tidy three-state models are genuinely contested by other scientists. Similarly, the idea that psychedelics heal by retuning vagal tone is a fascinating, actively studied, but very early-stage hypothesis. And those vagus-hacking gadgets you see marketed all over your social media feeds, the clinical evidence for them is currently pretty thin, to say the least.
Ultimately, the vagus nerve proves that our mind isn't just sealed inside our skull, dictating orders to a passive body. It relies on a heart that speeds and slows, a gut that churns, and an immune system that flares and settles. Calm isn't just a choice you make in your head. It is a physiological state the whole organism enters when it finally senses it is safe. As the source text beautifully puts it, much of healing, in the end, may be the work of helping a nervous system remember in the body itself what safety feels like. So I'll leave you with this. How can you help your own nervous system remember that physical feeling of safety today? Thanks for joining me on this explainer. Keep learning, stay curious, and I'll catch you next time.